Hello Year 10. Today we are going to be sketching parabolas using factorisation. So parabolas aren't always in turning point form. Often they are in the trinomial form with the a equals x squared plus bx plus c. So if we get an equation of a parabola like that, there are some steps here to follow that will help us sketch the parabola. So step number 1, you want to find the x-intercepts. And that means that you will let y equals 0 and you will factorize and solve your quadratic for x. Then you also want to find your y-intercept by letting x equal 0. Then you want to find your turning point, because that's an important feature of a parabola, is where the turning point is. So there are two ways you can find the x-coordinate of your turning point. First of all, we have this formula here, x equals minus b over 2a. That's called the axes of symmetry formula. The a and the b come from your quadratic equation. So up here, the a is whatever's in front of the x squared, the b is what's in front of the x, and the c is the number on the end. So you take those numbers, you put them into that formula, and that will give you the x-coordinate of the turning point, which you will then have to sub in to your original equation to find the y-coordinate. The second option for finding that x value is to average the two x-intercepts that you have found in step 1. So either of those options work. And finally, once you've found all of those things, you plot it all onto your Cartesian plane, making sure that you mark the x and y intercepts and your turning point. Okay, so we're going to work through those 5 steps to help us with these questions. So question number 1, sketch each graph showing the x and y intercepts and find the coordinates of the turning point. Okay, so there are all the things that we were just talking about. Step number 1, you don't have to do them in this order, but it's nice to have structure and something to follow for those of you who this might be new for you. So step number 1 is that we want to let the y equal 0 and put that into our equation so that we can solve for x. So y equals 0 in my equation would give 0 equals x squared minus 5x. To solve that, I'm going to factorize the x out. So it's a common factor. And I get x bracket x take away 5. Using null factor, I would get the solution that x is equal to 0 or x is equal to a positive 5. Okay, so that's step 1. Step 2 is that we want to find our y-intercept, which is when the x is equal to 0. If you put x equals 0 into this equation, we have 0 squared minus 5 times 0. That's just 0, so y is equal to 0 as well. That's step 2 done. Step 3 is probably the newish one, where we want to find our x-coordinate of our turning point. So because I have my two x-intercepts here, 0 and 5, I'm going to use the method of averaging those intercepts. So right in the middle would be 0 plus 5 over 2, which means the x-coordinate of my turning point is 2.5. Then in step 4, I want to sub that x-coordinate into my original equation, which is back up here. It's y equals 2.5 squared minus 5 times 2.5, because I want to find the y value that goes with that. That equals negative 6.25. So finally, step 5, my turning point is 2.5 for x and minus 6.25 for the y value. And all that information I now want to put on my graph. So over here on the side, hopefully you've got some room left. Starting with step 1, we found that the x-intercepts were at 0 and at 5. So I'm not really putting a scale on here, but I'm just marking those values on my graph. Then I found that my y-intercept was also 0, so that's already marked because that's the origin. And my turning point is 2.5, which is directly in the middle of my x-intercepts, down to negative 6.5. So that point there, and again, not to scale, but because I'm labeling everything, that doesn't matter about the scale. So 2.5, comma, negative 6.25. And my parabola looks like that, with my x and y intercepts and my turning point labeled. Let's do that again. Another question, part B. So I'm going to follow the same 5 steps to sketch this parabola. So step number 1 was that we want to find when the y is equal to 0 so that we can find our x-intercepts. So that would be 0 for the y equals, I'm going to factorize this quadratic while I'm at it. So the two numbers that times to give minus 12 and add to give a minus 4 are negative 6 and a positive 2. Solving that will give me x equals positive 6 or x equals negative 2. Second step, we want to find the y-intercept, which is when the x equals 0. If you put x equals 0 into the equation, x squared is 0, minus 4x is 0, so the only thing that would still be there would be the minus 12. So my y-intercept is negative 12. Okay, step 3. We want to find the axes of symmetry, which is the x-coordinate of the turning point. This time, just to show you the other method, I'm going to use the axis of symmetry formula, which is x equals minus b over 2a. The a would be the number in front of the x squared, which in this case would be a 1 because there's nothing else there. b is minus 4, c is the minus 12, but we don't need the c for our formula. So subbing in, I would get minus from the formula, and b is minus 4 over 2 times a, and a is equal to 1, so 2 times 1. So minus 4 is just 4. 4 divided by 2 is 2. Next, we need to find the y value that goes with that. So step 4, we sub x equals 2 into our original equation, and we would get y equals 2 squared minus 4 times 2 minus 12. That equals 4 take away 8 take away 12 is negative 16. Step 5, which I'm almost running out of room for here, but step 5 is writing that as that turning point as a coordinate. So the x value was 2 and the y value was negative 16. Putting that on a graph. Going through our steps 1 to 5 again to put it all on the graph that we're drawing here. So my x-intercepts are at negative 2 and a positive 6. So make sure you label those numbers, negative 2 and 6. Our y-intercept is negative 12 and our turning point is at 2, negative 16. So I'm going to start with the turning point down here, 2, negative 16. And then when I draw my parabola in, the spot where it crosses through here will be negative 12. And that's it. Let's do this again. Question 2. Sketch the graph of the perfect square. Y equals x squared plus 8x plus 16. So perfect square means that I can factorize that to be y equals times to give 16 and adds to give 8 would be 4. It'll be x plus 4 all squared. But what does that mean for my 5 steps? Well, let's go through them again. Step number 1, we're going to sub in when y equals 0. I'm going to put it into my factorized version. So it would be 0 equals x plus 4 all squared. I'm going to square root to get rid of the squared on that. So that would be x plus 4 equals 0, because square root of 0 is still 0. and then moving the 4 across, we get x equals minus 4, which is only one solution. Normally we get 2, or often we get 2. Next step, when y equals 0. If we put y equals 0, it's probably easy to think about the original equation for that, because it'd be 0, 0, and that means that the 16 would be the y-intercept. Sorry, that should say when x equals 0. Y equals 16. Then step 3, we want to find the axis of symmetry. So we only have one x-intercept, so let's use our formula, minus b over 2a. So we need the expanded version for that. So a would be 1, b would be 8, c would be 16. That would be negative 8 over 2 times 1. That is negative 4. Sub the negative 4 into the original equation. You might be seeing something interesting happening here, because minus 4 was my x-intercept. If you sub minus 4 into the original equation, you're going to get y is equal to 0. So the turning point is the point minus 4, 0. That's step 5. What has happened is that the turning point of this parabola has been moved horizontally. So instead of the typical parabola that has the vertex on the origin, the vertex is now at minus 4. So it is the x-intercept. It is also the turning point. The only other thing that we have from there, our parabola is coming up. The only other bit of information is my y-intercept, which is at 16, because my turning point and my x-intercept are all there at that minus 4. So that's it. Question 3, determine the turning point of that equation. Now, we're not asked to draw the sketch, which means we don't need the x and y intercepts. We don't need to do all of the steps. We just want the turning point, which means I could go straight to what would have been step 3, where we use our formula, x equals minus b over 2a, to find that axis of symmetry. So a is going to be 5, b is minus 10, c is the 5. Subbing that in, we would get minus 10 over 2 times 5. That is equal to 1. So the x-coordinate is 1. Sub that in, so sub x is equal to 1 into the y equation, and we would get y equal 5 times 1 squared minus 10 times 1 plus 5, and that equals 0. So the turning point, therefore, the turning point is x is 1, y is 0. We need to write that as a coordinate. But that's it, we're finished. Question 4. Find the equation of the following graph if it is in the form y equals x minus a in brackets and x minus b in brackets. Find the value of a and b, and also find the coordinates of the turning point. So, because the form that we're asked to put this in is factorized, the value of a and b would come from the x-intercepts, the minus 1 and the 3. But we're basically doing null factor in reverse. If the solution is minus 1, that means in the bracket we should have had x plus 1. And if 3 was the solution, then that would be x minus 3 for the second bracket. So the value of a and b would be that a is equal to a negative 1 and b is equal to 3. Because of the minuses, they become the opposite symbol from there. Okay, so we've done step number 1. We've found the equation in that form. Now we need to find the turning point. Because I haven't got an expanded equation, I'm going to use the axis of symmetry formula. Actually, sorry, not. I've got the intercepts. So instead, I'm going to use the intercepts to find the x value. So x is going to be equal to, I'm going to average my values, which is minus 1 plus 3 over 2. That makes x is equal to 1. Then I sub x is equal to 1 into my equation, which will give y equals 1 plus 1 and 1 minus 3. That's 2 times minus 2, which is negative 4. So the coordinates of my turning point are 1, negative 4. Okay, question 5, lucky last one. Sketch the quadratic y equals negative x squared plus 8x plus 9. So I'm going to start by factorizing out the minus sign. So I have x squared minus 8x minus 9, which means that I can factorize that trinomial, which would be x minus 9, x plus 1. That makes it a little bit easier for me to do step number 1, which is to find the x-intercepts. The x-intercepts are when y equals 0, but because I already have it factorized, I can read those solutions straight away, which would be x is equal to 9 and x is equal to minus 1. Part 2, we want to find our y-intercept, which is when x equals 0. In the original equation, the number on the end is the 9. That's my y-intercept. Step number 3, the x-coordinate of my turning point. I'm going to add together my values, so I'll have 9 plus minus 1 over 2. So 8 over 2 is equal to 4. And then step 4, sub that in to find the y value. So y equals negative 4 squared plus 4, 8 times 4 plus 9, which is equal to 25. Step 5, the turning point is 425. Okay, drawing that information. The turning point, or let's start with our intercepts. We have minus 1 and a positive 9. And we have a turning point at 425, so somewhere way up here will be 425. And this, probably unsurprisingly, is a concave down parabola, and we know that from the minus that was in front of the x squared. The y-intercept through here is at y equals 9. Okay, so everything is labelled. Our sketch is complete. All right, that's it for our theory section. Time for you to do exercise 9C.